Hi students, in this video we are going to see one of the multiplexer problem. The frequently asked in the almost in all university examinations, particularly in non-university examinations. So you can see the first problem. Implement the following Boolean function using 8:1 MUX f of a b c d equal to sigma m 0 1 3 4 8 9 15. I think it will be asked in the April 2015. Afterwards also it will be most of the time it will be asked in our universities. So you can see the problem. In this particular problem, the function f of a b c d, it's having the four variables, but we have to implement the same function in the 8:1 multiplexer. In this particular 8:1 multiplexer, the number of variables used is only 3. So we are going to analyze this particular problem. The given function, it's having the four variables, but the given multiplexer, it's having only 3 variables. So we have to implement the 4 variable function in the 3 variable multiplexers. So how can we do that? Just we can see the things. Before we are entering into the implementation, we must go through the multiplexer fundamentals, and then we can come for the particular problem. You can see the fundamentals of the particular multiplexer. Right, sir. This is known as multiplexer. In this multiplexer, it's having the 2 to the power of n number of input lines, and also it's having a single output. In this multiplexer, we are having the n number of control lines. So from the input itself, it is the input, we are having the 2 to the power of n number of input lines, but we are having the n number of control lines only. So we are going to implement the 8:1 MUX means, so 2 to the power of 3 will be equal to 8. So the n will be equal to 3. So the 3 control lines will be needed for implementing the 8:1 multiplexer. Right, sir? So in this particular case, we already mentioned that the multiplexer it's going to select one of the input to the output based upon the control lines. So this will be the function. So our given multiplexer is 8:1. It's having the 8 variables. Right, sir? Just we are going to we have to draw the particular tabulation for the particular implementation tabulation for the particular given multiplexer circuit. So in this multiplexer, they are given the 8:1 multiplexer. It's having the 8 data lines or 8 data input lines. So the data lines, it can start from D0, D1, D3, D2, D3, D4, D5, D6, D7. It's having the 8 lines. So we are going to implement the 4 variable means the last 4th variable. The first 0 to 7, the 4th variable is 0. The next thing 8 to 15, the 4th variable is 1. This will be in the sequence. So in this particular case, we are going to introduce the a bar is 0, a equal to 1. So now we are going to, with the implementation table, we are going to take the input value, the 4th variable values a and a bar and a. So a bar represents, it is a 0 will be combined with the D0, D1, D2, D3, D4, D5, D6, D7, and also a represents the 1 will be attached with the all the input lines. So 1 D0 equal to 000, 1 is 8. So now we are going to assign the particular output variables in the corresponding cell. So a bar D0, it can represent 0, 000 equal to 0, 0, 001 equal to 1, and then it can continue up to 7. There is no change in the first a bar row. Now we can go for the a row. A is considered as 1, so the D0 is considered as 000. So 1 000 equal to 8. So and then we are going to use the same sequence for the particular remaining numbers up to 7, 9, 10, 11, 12, 13, 14. Now we can see the problem and then we can come for the same table. We have to mark some values. We can see the problem is given with the variables sigma m equal to 0, 1, 3, 4, 8, 9, 15. So we have to encircle the particular given mean term in the implementation table. So we are going to encircle the mean terms 0, 1, 3, 4, 8, 9, 15. Right, sir? Now you can see that we are going to encircle the 0, D0, D1, D3, D4 and D8 and D9 and D15. Right? Now we are encircled to the given problem in this particular case. Just we can see the D0 column. D0 column, the two variables A bar and A variable, the two cells are encircled. You can see the D2 column, that both the circles are not encircled. You can refer the D3 and D4, the upper row variables are encircled, 3 and 4 are encircled. We can see the 15 D7 column, 15 is encircled in the lowermost column. Right? If we are encircled both the cell, the particular column value will be filled with 1. So we are going to mention in the D0 column, we are going to mention it as 1, D1 also 1. So and also we have to consider the same thing for the uncircled cells also. We have to consider the D3, D5 and D6. We are going to mention it, the value will be 0. Both the mean term values are encircled, both the cells values are encircled means if you are going to put it as 1, if both the cell values are not encircled means it will be represented with 0. Now we can go for the D3 and D4. So the D3 and D4, it will be in the first row. The value of the first row is A bar. So we are going to mark it as A bar. The 15 will be available in the lower row. So in this particular case, the value will be A. So we are going to mark the 4 types. One is the both encircled means we have to mark it as 1. Both not encircled means we are going to mark it as 0. We are encircled in the upper case means upper row means it is encircled, it is named as A bar. In lower row means A. These are all the consolidation of the particular statements. If the both the rows are encircled, put 1, else put 0. If any one of the row is encircled, put it in the first row. If anyone is encircled in the first row, it is put A bar. If it is any one of the cell is encircled, cell value is encircled with in second row, we can put as A. And also in this particular case, we have to consider the 3 cases. One is the input, output and control lines. In our given problem, the input is starts from D0 to it can ends with the D7. It having 8 input lines, and also F will be equal to the function, like, or otherwise F will be the output function, or otherwise we are going to consider as a F is output. X, Y, Z, it can be represented as a 3 control lines. So in our data lines, it's we are having the 2 to the power of 3 numbers of data lines. So in this particular MUX, we must need a 3 control lines X, Y, Z. It is named as X, Y, Z. Sir, you can see this. So in this particular case, the MUX logic diagram will be, block diagram will be drawn in rightmost of the screen. So it's having the 8 input lines. The input lines will be started from D0 to D0 and ended with the D7, D0, D1, D2, D3, D4, D5, D6, D7, and it's having the one of the output is Y, right? Or otherwise the function value Vf will be maybe assigned. So now we can see the things. So the D0 and D2, the values are 2. you can consult, you can refer the implementation table. The D0 will be marked with the assigned values 1, D1 is assigned values 1. So both are connected together and it will be connected with 1 in the circuit diagram. You can refer in the circuit diagram. And also the remaining cases D2 and D5 and D6, three numbers, three input lines D2, D5, D6 are both are connected together and it will be connected with 0. And then the D7 will be connected with A. D3 and D4 connected together and it will be connected with A bar. So now we are implemented the given 4 variable function with the 8:1 multiplexer. Right, the given problem is sigma equal to sigma m mean term of 0, 1, 3, 4, 8, 9, 15. So it will be implemented in 8:1 multiplexer. So we are implemented the 4 variable function with the 3 variable multiplexer. Thank you students.